Alright, so welcome to the fourth part of my C++ SFML tutorials. In this part we're gonna cover how to render stuff onto the screen. I always do it the traditional OpenGL way by, just you'll begin, you'll quads, you'll end, then just add the vertices in here, or I use vertex arrays, stuff like that. You can do it that way, but SFML comes with a class, a object called a sprite. So it's SF sprite, and just call it sprite. And this sprite, you can assign stuff to it. So set image, and there's another of the SFML classes that comes with SFML called an image. What's great about an image is that you can bind it just like a texture. So you can combine, you can create an image and just bind it and then use traditional OpenGL rendering. And with the sprites you can just do set set position. You can set the color, the center, a lot of stuff. So that's that. So let's create an image as well. Image and image. Let's paint something. Gonna see my awesome painting skills. Alright, so it's a bloody ghost. Let's just save this, and documents and projects .1. Alright, saved, and let's load it in. So image, and we can do an if save. If image dot load from file, pass in the name. So I saved it in the same location as my CBP file, so I don't have to specify any special paths. So if that see, it returns a boolean. So if that is equal to false, then so if this is equal to false, it failed to load ghost. Alright, and we can return -2. Else, it returns, so we don't need to have an else. And once that is loaded, we can do sprite dot set image to that image. Let's set its position to like middle of the screen. Right, and then let's just render this out. I probably want to do, I wonder if that's how it is. And there we go, we have the sprite rendered. It's quite small, but that's just because it's a 32 by 32 image. So all we have to do in order to scale it is to sprite dot set scale, then scale it up, and it's twice as big. Now, yeah, I don't really use these classes. I create my own, so, but that's good. You know, it's good to know what kind of options you have. And yeah, let's do it my way, or not my way, but the way I used to do it. So the first thing we're gonna tackle is how to load textures. So we want to create a texture bank, and if you watched my logical tutorials, you will remember this class. This class is going to contain a standard map, and we're going to have a string for keys. Alright, and then of course I want to include SFML. Alright. I'm going to have two different functions. We want to have one function to return a texture, and that texture is a GL unsigned integer, and then you just call it get texture and the name of texture, and then we want we can have a bool load texture, the path, and then the name. Now, as a private variable, I'll want the map have oh crap, I'm so used to Java. Okay, I want to have as a key string, and then as a value I want a unsigned GL integer. Just call this textures. So let's just start loading. And here we can actually make use of the image class. So I'm just gonna create a new image. I'm gonna make sure that load from file with the path is equal to true, and if that is true, we can create our texture, our GL texture, and call yen textures, the number of textures, and then the texture yeah, I'm gonna have to pass in that as a reference, and then we can bind the texture as in GL texture 2D. And one thing you have to remember is to enable textures in OpenGL. So let's go back to the core class, and in our init we can just GL enable the texture 2D, just like that. Alright, so now we know it's always enabled, so we can use it. Now we can specify how to render the texture when it's close to us and when it's far away. So we can do a GL text parameter ref, the target 2D, GL texture 2D. Then we do what if we are specifying the near or the far. Yeah, if we specify the far or near part. So GL texture mag filter. Now I'm not quite sure. I think mag is when it's far away, and min when it's close, or it's the reversed. Yeah, so I often use two of them. Either I use GL nearest or GL linear. Now the difference is that when you use linear, the texture will be blurry, if you resize the texture, it will be blurry, and if you use nearest, it will always be pixelated. So if you resize it, you will still see the pixels. The pixels will be untouched. So I'm just gonna specify the nearest for both of the filters, because I don't want blurry textures when working with 2D games. Especially not if you work with tiled graphics. If you have a tile sheet, because then the blur will kind of steal some colors from the colors, you know, around the pixels, so it might steal some colors from another tile. Then we want to create a texture, so you'll text image 2D. Pressing that and the texture 2D. Then I think we have something called the level. I'm just gonna set at 0, the internal format. And what's great with SFML is that you can always specify the red, green, blue in alpha. You don't have to make sure that the image contains an alpha channel. This has always worked for me. In STL, however, you had to check for that, or else it would fail. Alright. Come on, it's hard to remember these. The width and the height. So we just have to take our image dot get width, and then the image dot get height. Then I think we have something called, I don't know, border. I said it's 0. Format again, red, green, blue, and A. Yeah, whatever. And now we have what kind of type is the pixels stored as, and I'm just gonna take yield unsigned byte. Alright, and then the pixels, so image dot get pixels pointer. Alright, so now our texture has been created. Now what if you want to know more, about what the border and level do, or what these two do, you can just Google. But these two they have to do with in what order that color values come in, so in the image format. So that's what that is about. Alright, so let's take our textures map and then dot insert, and then make pair, just like in an order map, and then we pass in our name, because that's our key, and then the texture as our value. We can return true if it did not fail, else we can return false. Alright, so get the texture, and here it's quite easy. We just have to check for if the textures dot find the name key, if that is not equal to the textures dot end. So if we found it somewhere within the textures map in the container, then we can return it. If not, we have to return null. And that's one thing you have to check for when you use the get texture. You check for, make sure that it's not null. If it's not null, then it's safe to use the textures. If it is null, then there are no textures. So it's quite a nice way to check whether the texture exists or not. So now our texture bank is ready, it's done, and now we can just create an instance of it. So I'm gonna include it in the core class, and create a new texture bank instance. I am not gonna make it a pointer. Let's just keep it simple. Then we can remove this and do a texture bank dot load texture. The path ghost.png, and the name can just be ghost. Then in the render function, let's just render simple OpenGL quad. Oh. Remember, you also need to specify the texture chords as well. Okay, we also have to bind our textures, so texture bank dot yield bind texture. Now, so to make sure that we don't crash if the texture doesn't exist, we can do if texture bank dot get texture ghost is not equal to null. Alright, and if we now run this, we get an error. That's because this is not of type void. Yeah. If we run this, we get our ghost in the top left corner of our screen. Alright, so that's awesome. To move him, you just use yell translative and keep it as good practice to translate back everything you translate, or else you can get funky results. As well, the same goes with rotation and stuff, as you can see there. Right. Now, I should maybe talk a bit about the way I put vertices out. So I'm just gonna try and explain this. If you know that, you can just skip the rest. This is the last thing I'm gonna do in this tutorial. So this is my square with my ghost, and you see here the first vertex is at 0, 0, so that is this corner, and then 32, 0, this corner, then 32, 32, this corner, and then 0, 32, this corner. And this will make OpenGL take these corners, oh crap, take these corners and, you know, combine them into a quad. You can also specify them in another way. You can specify them like this and that, and then go here and like this. I believe that should work. And, you know, just I don't think you can specify it like this though. Like first there, then there, then there, and then up there. That will give you a weird result, I believe. I haven't done that. So just keep that in mind. Try and follow this pattern when you specify vertices in squares. And the texture coordinates just follows the vertices, just that they only range from 0 to 1. So this corner is 1, 1. This is 0, 1, 0, 0, and 1, 0. Just to keep that in mind. So if you want coordinate like in the middle of the square, you have to take 1 and divide it by half the width of the square to get that X coordinate, for example. Same goes for Y, and stuff like that. Okay, so I hope I made that clear, and this was about texture and rendering. So this was probably 2 parts, maybe one really long part, but nonetheless I hope you enjoyed, and I'll see you in the next part.